Hello, this is our chemistry revision video number 1. The first video we're going to have is going to cover things like periodic table, atomic structure. Second video that I'll do will cover ionic compounds, covalent compounds and ions, and the third video, the chemical reactions that we've looked at. What you need to know about the periodic table is that it runs in periods and groups. So the groups run down in columns and the periods run across in rows. So if I was to look at group 1, I'm looking at everything in the first column here. Group 2, this is my second column. It's got a 2 up the top. It's also got the Roman numerals 2, so you know it's group 2. Our third group is over here. Starts at boron. We don't include all our transition metals. So our third group, our fourth group, our fifth group, sixth, seventh, we have 8 groups. Periods run across. So my first period is hydrogen and helium. That's it. My second period, lithium, beryllium, boron, etc. So what do groups and periods mean? The groups tell you how many electrons in the last shell for that atom. Everything in group 1 has 1 electron in the last shell. Over here, group 4, everything in this group has 4 electrons in its last shell. The periods tell us how many shells we've got. So period 1 only has 1 shell, and the first shell can only take 2 electrons. So we've got hydrogen here in period 1, group 1. He's got 1 shell, 1 electron. We've got helium. He's got 1 shell, 2 electrons because he's in group 8. Now he's an exception. 8 can also mean a full outer shell. Now the first shell can only take 2, so he's full on his 2 outer shells. Neon, argon, krypton, etc., they all have 8 electrons in their outer shell, so they follow the pattern of group number meaning number of electrons in the outer shell. Alright, so what else do you need to know about the periodic table? You need to know that the first group is called alkali metals. My second group is called alkali earth metals. Go to your 7th group is halogens, and the 8th group is noble gases. You need to know that all the metals are on the left-hand side of the table. All my non-metals are on the right-hand side. It's a much smaller section. And I've got this green bit here. These are non-metals. Sorry, not non-metals. These are metalloids. Metalloids share some properties of metals and some properties of non-metals. Alright, the periodic table also tells us a little bit more. So if we zoom in, let's say beryllium, you've got the symbol Be, so they contain the atom symbol. You've got the number 4 here, which is the atomic number, and you've got this number, 9.01218. This is the mass number, and we'll get to that in a minute. Okay, so before we go on, here's just a quick summary. Groups. Columns running down, there's 8 groups, represents the number of electrons in the last shell. Group 1 is alkali metals, group 2 alkali earth, group 7 halogens, group 8 noble gases. Our periods, rows that run across, represents the number of electron shells. And, I didn't say this before, but the further down you go for your rows, the more reactive those elements become. Okay, so here I've just zoomed into one part, or one element in the periodic table, chlorine. Chlorine, capital letter C, little l. When you are looking at the symbols for atoms, always it starts with a capital letter. Sometimes it has a second letter, which will always be lowercase. Sometimes it doesn't. Alright, so what have we got? On chlorine, you've got the symbol, you've got the name, you've got 2 numbers, the number 17 and 35.453 here. What do they mean? The smaller number is always the atomic number. The atomic number is the number of protons. It also tells you the number of electrons in the atom, but we say it's the number of protons because we know that the number of electrons can change. When an atom becomes an ion, it will lose or gain electrons. So since that can change, we say that the atomic number is the number of protons. Our second number is our bigger number. It's our mass number. It tells us the number of protons plus neutrons. So basically it's telling you the weight of everything inside the nucleus of the atom, because inside the nucleus is the protons and the neutrons. The electrons are so small they barely contribute to the weight of the atom, so they're not counted in the mass number. Alright, I can calculate the number of my protons and electrons by looking at the atomic number. So I know that, I know that there are 17 protons and 17 electrons in this atom. But if I want to know the number of neutrons, I need to go 35, and I'm going to round it to 35. If it was 35.5 something, I'd round up to 36. 35, my protons and neutrons, minus my protons to give me my number of neutrons. (18 neutrons). Alright, so I've set up 3 different atoms for you. I've got Na, P and Ne, sodium, phosphorus and neon. You need to calculate the number of electrons, protons and neutrons for each. So have a go now. Alright, hopefully this is what you've got. The atomic number for sodium is 11. That means it's got 11 protons and 11 electrons. Its mass number is 23, so 23 minus 11 is 12 neutrons. But phosphorus, atomic number 15, so 15 electrons and protons, 16 neutrons. 31 minus 15 is 16. Neon, 10 electrons, 10 neutrons, and 10 protons. Okay, so now I'm going to move on to Bohr's shell model. Chlorine has the atomic number 17. That means he's got 17 protons. It also means he's got 17 electrons. So if I was going to draw this atom, I draw a nucleus, and I don't need to draw the protons and neutrons in my nucleus. And I go, right, 17 electrons. Well, the first shell can take 2 electrons, so I've got 15 left. So I move to my next shell because that shell's full. My second shell can take up to 8 electrons. That's a total of 10 so far. So I've got another 7 to go. So I need to move out to my last shell and draw 7 electrons. 1, 2, 3, 4, 5, 6, 7. So what I'm doing is these are my electrons, and electrons are particles with a negative charge. Inside the center are the protons, and the protons have a positive charge, and there's also neutrons in there, and my neutrons do not have a charge at all. Neutral, 0. So what is my electron configuration for this shell? Well, I start with my inner shell and I move out. My inner shell has 2 electrons, my middle shell has 8 electrons, and my last shell has 7. This is the valence electron shell. Valence is just the outer shell and the outer shell electrons. So 287 is my electron configuration. You'll also notice that chlorine is group 7, 7 electrons in the outer shell, and it is period 3. I have 3 shells. Alright, so I want you to practice by drawing a shell diagram of magnesium, neon, and calcium. Alright, so here is my magnesium atom. He's got atomic number 12, so 12 electrons. 2 in the first shell, 8 in the next shell, that's 10, 2 in the last shell. That means this guy's group 2 and period 3 because there are 3 electrons and 3 electron shells and 2 electrons in the last shell. Alright, my next one, neon. Neon has atomic number 10. So draw a nucleus, 2 in the first shell, it's full. I've got another 8 to go, 1, 2, 3, 4, 5, 6, 7, 8, and that shell's full, but that's all he needs. So his electron configuration is 2, 8. And I didn't do magnesium. Magnesium is 2 in the first shell, 8 in the second shell, 2 in the last shell. Last one, we've got calcium. Calcium has 20 electrons. So 2 in the first, 8 in the next, that's 10, so I've got another 10 to go. We can do another 8 electrons. That's 18. So I need another 2 more. He's also in group 2. His electron configuration is 2, 8, 8, 2. Okay, so that's it for this first video.